Good morning all of you, hope all are doing well. So in the previous class we learnt about operations on whole numbers. Particularly we learnt operations under addition. Four properties we learnt under addition. What are those? First one is closure property. That means if we added two whole numbers, then the result also a whole number. And the next commutative property under addition. That means if we added two whole numbers, then reversing the order also if we added, the result will be same. That means a plus b equals to b plus a is said to be as commutative property. Next, associative property, irrespective of grouping. A, B, C are any three whole numbers. You group first two or last two, then add, then the result will be same. That means A plus B plus C is equals to A plus B plus C. The next, identity, additive identical property. That means if you add 0 to any whole number, you will get that number only. Means A is a whole number. A plus 0 gives us A only. Here 0 is called additive identity. So on these four properties we solved some problems in exercise 2.3. Then after that continuation fourth main. The fourth main is given as asking us to find the value of x for which each of the following statements becomes true. So we have to find here some statements given A, B, C, and D. You have to do homework. D also given in fourth main. That one you have to do homework, and A, B, C I will explain. So in these three statements, we have to find the x value by using properties of addition. The first one, for 45 plus 37 is equals to x plus 45. So we know commutative property A plus B equals to B plus A. By reversing the order, the sum will remain same. That means A plus B is equals to B plus A. A plus B is equals to B plus A. Reversing, then also the sum will same. That only commutative property tells us that. Therefore, x is equals to 37 by commutative property. Next here also observe same commutative property only. X plus 35 is equals to 35 plus 49. So just by reversing the order, the sum will remain same. The commutative property tells us by using commutative property we can say x is equals to 49 by commutative property. Or else you may remain the both side you observe, left hand side and right hand side of the equation of the equality sign. So here 45, here 37. So here 45. So 45 and 45 is same in the both side. What remains here? Here x, here 37. That means x means 37. Like that also you can analyze and easily you may write. Here also left hand side, right hand side. Here x plus 35. Here 35 plus 49. Here 35 and 35 are same in the both sides. Then what's the remaining one? Here x that is equals to 49. Like that also you may analyze and write. Coming to next. 45 plus x is equals to 45. When we will get same number, identical number, when we add 0 to that given number. That means by using additive identical property, we can say here x is equals to 0. Then by additive identical property. So next D as I told we have to do homework. Next fifth main. Fifth main asking us State the property in each of the following. So here A, B, C, D, E, F. So 6 statements are given here. We have to tell the name of that property. What property is used in that statement? So A, B, C, D I will explain, and E and F you have to do homework. And coming to A, 37 plus 73 is equals to 73 plus 37. Name of the property? Commutative property. Commutative. Under addition. Just reversing the order. The next one. 105 plus 85 is equals to 85 plus 105. Again reversing the order. So name of the property? Commutative property. Here look, 0 came. 0 came means only one property we are having. Additive identical property. So 37 plus 0 equals to same 37. Identical property. Under addition. And the next here look, 3 numbers are used. 3 numbers A, B, C. By using 3 numbers only one property we are having. What that is? Associative property. By grouping, irrespective of grouping, the sum of 3 numbers remains same. That means A plus B plus C equals to A plus B plus C. That only here. The first 2 numbers are grouped here. Here the last 2 numbers are grouped. However you group, irrespective of grouping, the sum will remain same. So name of this property is associative property. Associative. So observe E and F in the textbook, then write the name of those 2 properties also. And the next step, 6th main. 6th main is given some statements. You have to tell that one as true or false. True or false. So 6 statements are given. So read carefully that statement. Just write down it is true means true, false means false. For example, the first one is sum of 2 odd numbers is odd number. Take 2 odd numbers 3 and 5. Add them. What you will get? 8. Now you tell sum of 2 odd numbers is odd number. No, it is even number. So statement is false. Next, second statement is given in 6th main. Sum of 2 even numbers is even number. Take any 2 even numbers 2 and 4. Add them. Then result is even number. So that means given statement is true. So sum of 2 even numbers is even number. So like that 6 statements you verify and tell whether it is true means write down true, false means write down false. So that one also you have to do as homework. Next, properties of subtraction. Properties of subtraction. Under addition we check. We added 2 whole numbers and we are getting the same result as whole number only, that is closure property. That means under addition whole numbers are closed. That is closure property. And next, by reversing the order, then also the result will not change. That is commutative property under addition. That means whole numbers are commutative under addition. Next, irrespective of grouping, then result will be same in addition. If you added any 3 numbers, irrespective of grouping, the addition remains same. That is said to be as associative property. That means whole numbers are associative under addition. And next, coming to subtraction. Properties of subtraction. We will see under subtraction the whole numbers are commutative or not. Under subtraction the whole numbers are associative or not. Under subtraction, the whole numbers are closed or not. So these things, these three things we'll check. The first one is take any two whole numbers. So 2 and 5. 2 and 5. And next 7 and 3. I will subtract them. 2 minus 5 and 2 minus 5 means minus 3. Next 7 minus 3 means 4. In the subtraction of any two whole numbers, the result we are getting sometimes whole number and sometimes may not. That means we cannot say here the whole numbers are closed under subtraction. Surely whole number is not coming. Sometimes other than whole number also coming. It is an integer, not whole number. Whole number starts from 0, 0, 1, 2, 3, 4, 5, 6 and so on. Negative number not there in whole number. So, sometimes in the subtraction of whole numbers, we are not getting again whole number. So, we can say whole numbers are not closed under subtraction. Generalize if A, B are any two whole numbers, then A minus B may or may not whole number. So, we can say whole numbers are not closed. Here closed property is not surely we can tell. Closed property is true under subtraction. Sometimes it may true, sometimes it may false. And the next, associative property. First, commutative property we check. That means by reversing the order. Take any two whole numbers 7 and 5. Okay, 7 and 5. Any two. Subtract them. 7 minus 5 is 2. Now reverse the order and subtract them. That means 5, 7. 5 minus 7 is equals to minus 2. The result is same here too. Here the result is minus 2. Both are same? No. That means whole numbers are not commutative under subtraction. So under subtraction, commutative property is not true. Same like that. Closure property is not true under subtraction. So commutative property also not true under subtraction. But it is true in addition. So we can generalize if A, B are any two whole numbers, then A plus B is, A minus B is not equals to B minus A, always not equals to B minus A, except 0. 0 also may take, it will not come. So, you can generalize A, B are any two whole numbers, A minus B is not equals to B minus A. Next, associative property. We will check associative property under subtraction. Take any three whole numbers. So 7, 5, 3. Group them. First to do subtraction, I want to subtract them. 7 minus 5 minus 3. Two ways we can do this subtraction. How like means by grouping the first two. Next, by grouping the last two. How we did differently grouping in addition. Grouped the first two and grouped the last two. Then also we got result the same in addition, under addition. So same thing we will check for subtraction. So next, group the first two. That means subtract 7 minus 5, 7, 5 from 7. What we will get? 7 minus 5 means 2 minus 3. 2 minus 3 is minus 1. into here. 7 minus half, 5 minus 3. 5 minus 3 means 2. Now 7 minus 2 is 5. Both are same. Here result is minus 1, here result is 5. By grouping first two and last two, we are not getting the results. In addition we are getting, but in subtraction we are not getting. So here also the associative property fails under subtraction. So we can say again, we can generalize if A, B, C are any three whole numbers, A minus B minus C is not equals to A minus B minus C. Under subtraction, not closed. Under subtraction, not commutative. Under subtraction, not associative. Whole numbers are. But under addition, associative, commutative, and also closed. So the main difference we have to observe. So now exercise 2.4. So problem solution.